Welcome to the Profile Corner. Today's video is part 4 in the Mortise and Tenon series. In the last video, we created two mortise and tenon joints. We used a mortiser, specifically a hollow chisel mortiser, and the radial arm saw to create this joint. And it worked out really well for us using those specialized tools. And then for a little bit of interest, we used the PantoRouter to create a mortise and tenon joint that's tilted in 10 degrees in two different directions. And then we also used a 7-degree bit that has a 7-degree angle on each edge to produce a much more interesting joint that you might see used on a chair or on a stool of some sort to tilt the legs at a specific angle, such as that, so that the stretcher is horizontal. And so these were interesting joints. Now, where do we take this topic from these extremes? Well, we can go back to an earlier time. 35 years ago, I developed a jig that looks like this for creating mortises, and it was mounted onto this Bosch 1617 AVS router at the time, and I was using it to cut mortises that look just like this into 4x4 redwood and also pressure treated 4x4s to create legs for English garden benches. And here's another mortise that was cut here. So we'll be doing the same thing today using this router. And in addition to this, we'll also be using another method that will be using one of these two other plunge routers. I'm still trying to decide which one we'll be using. What I've discovered is that the Milwaukee bushings that mount into the bottom of the router measure exactly 3/4 of an inch across when you mount a 3/4 inch bushing into the router, whereas the Bosch measures 4/1000 undersize. And I think that that's going to be a problem for us, so we'll probably end up using the Milwaukee router for doing the second type of a mortise joint that we'll be doing today using routers. And then once we finish with this, we'll be going over to the PantoRouter to see if we can't create one or two mortise and tenon joints over there using a custom-made template for one of those mortise and tenon joints. This is actually a smaller template than what we'll be using. The one that we'll be using has 4 of these instead of just 3. And we'll be taking a look at how I created the templates also before we start using it. Okay, so let's get started here. I have marked onto this board the location of 2 additional mortises, and we'll be cutting both of them using this router. Okay, so here's the board that we're going to be mortising into. I've got it marked where the 2 mortises will be going, and we'll be using 2 different approaches to cut these mortises. And the first approach, which I used 30 to 35 years ago, was to plunge straight down, just as we did at the drill press, and then do a half or 3/4 step over, and then plunge down again, do another half or 3/4 step over, plunge down again, and do that repeatedly all the way across. And then I'll come back and I'll make a full depth pass all the way across. The other way that you can do it is, since I'm using a 1/2 inch wide bit, I can actually go down a 1/2 inch at a time. So I can go down a 1/2 inch, make a full pass all the way across, go down another 1/2 inch, go in the opposite direction back, and then go down another 1/2 inch to reach full 1.5 inch depth of cut, and then make a full pass going all the way across. That seems to be a less efficient approach than the approach I'll be using here, and you'll be able to time the differences between the two. Now, this jig was originally set up because I didn't have an edge guide for this router, I set up a guide on both sides, but it was set up for cutting pressure treated wood, which was slightly over 3.5 inches wide, and you'll see that there's a little bit of a gap here side to side. So I need to be careful about that, and I'll just use the one side of the jig instead of trying to use both sides when I'm making these cuts. And what I'll do is I'll make a full depth cut on the one end of the mortise, come across and do the same thing on the other end, and then I'll go back and I'll make the cleanup cuts in between. Okay, so that mortise has been cut. Here's the result. It looks good to me, although we've got rounded edges here that we'll have to take care of using one or two different methods. Okay, so now let's try the other mortise down here, and we'll use the other technique of going down roughly a 1/2 inch each time. And we'll see if that's more efficient. Okay, so here's the mortise that was cut using the other technique. The walls are slightly smoother here. However, I think that the walls ended up actually a little bit over 1/2 inch wide due to the little bit of slop that's in the fence. Whereas this approach that I used going straight down did not do that so much. So we've got the two mortises cut. So we're good there. Now let's look at another approach for creating these mortises using the Milwaukee router that's over here, and we'll see if that method is any better. And just to make things a little more complicated, I'm actually going to cut these mortises angled so that this mortise is going to be over here and this mortise will be over here, and they'll both be 2 inches long, 1.5 inches deep, and we'll have to see how that works out for us. Okay, so I've got to do a little bit of setup here before we get started. I've swapped over to the Milwaukee router that's mounted into a plunge base. I have a 4-inch long, 1/2 inch diameter, 2-inch cutting length, white side spiral upcut bit mounted into the router. A 3/4 inch guide bushing is mounted into the base, and I've set it so that this bit is going to project out 1.5 inches, or actually 1 5/8 inches, when the router is sitting on this template. This template was created from 3/4 inch plywood. You've got one piece of 3/4 inch plywood here and a matching piece over here. And then here, I've glued in a section of plywood that's exactly 3/4 inch wide. I've got some double stick tape here, or double-sided tape, and I'll be using that to stick it onto the 4x4 that's going to be cut. And so I'm going to place this onto the board here, and I'm going to try to make it so that I've got an 1/8 inch on each side, and that way I'll know that the jig is placed correctly, because we're going to be cutting a 1/2 inch wide, and of course we're using a 3/4 inch wide guide bushing, so that means that there should be an 1/8 inch on each side. Now I can take a ruler and double check that, but it's going to be hard to get the ruler down inside there, so just eyeballing it should be close enough for this experiment. And if I were going to do this in some sort of a production run, I would actually put some end stops into here. I could possibly glue them in using super glue or something like that, something that would be removable. So I would have an end stop on each end of the mortise, but I'm not going to do that. I'll just be doing it by eye using this particular router, if possible. I will have some difficulty seeing down inside, so we'll have to work around that a little bit. But we can make that happen so that these mortises end up being exactly 2 inches long. I've got to look and see if I can spot the end of the mortise and try to get that bit lined up. To make it easier to make sure that I've got the right dimension, okay, I still didn't get this end cut perfectly, so let's do that end again. And actually, I'll just plunge it down, and then I'll try to make the cut. Extend it out just a little bit. Okay, so that one's been cut. Let's do this other one here. And unfortunately, this Milwaukee base is not retracting all the way, and so it ended up cutting some of the material I didn't want to actually have cut. But we can work around that. That's not a big deal. This is just a test piece. See how we're doing here. Okay, we've got to go a little bit further. Okay, so we've got that cut. And let's see what we ended up with. So here's our one mortise, and unfortunately, as I mentioned there, the router did not retract all the way, and so I ended up cutting about an 1/8 inch, maybe actually a 1/16 inch down, all the way down to there. And here's our other mortise that was cut. Okay, so if we were going to put in the same type of assembly that goes into here, but we wanted to have it at an angle, this approach would work. But I think that we definitely need to have end stops set up in here, because the guide bushing that's in the router here just doesn't allow enough visibility to actually see where those end stops on the mortises need to be. It takes a little bit too much work and too many trials to try to get that right. Okay, so now let's go over to the table saw and we'll cut tenons to fit down into our mortises. And the boards that we'll put the tenons onto look like this. They're 16 inches long, 3 inches wide, and 1.5 inches thick. They're actually a little bit under 1.5 inches by 1/32 of an inch. But we'll be putting 1/2 inch thick tenons that are 1.5 inches long onto this board. And so I've got the tenoning jig that we created in the previous video mounted onto the table saw. I have a rip style blade with 40 teeth on it mounted into the table saw. The rip style teeth, of course, are straight across rather than being angled as they would be on a cross cut or a combination blade. I've set so that it's 1 inch from the jig to the inside here of the tooth, and so that should leave a 1/2 inch tenon once both sides of this board are cut. And so we should be ready to get started here. What I think I'll do, because I haven't used this jig yet, is I'll push the board all the way through, and I'll turn off the saw before I back up the jig, just in case something bad goes wrong and the jig ends up getting twisted ever so slightly. I don't want to get kicked back with a saw. Okay, so we don't have the benefit of zero clearance on here, so we may get a little bit of chip out. Right now it's not looking so bad. So here's our first cut. So now we need to flip this around, just like so, and then we'll cut the other side. Okay, now I need to cut the other end. I should probably double check and make sure that I'm getting a 1/2 inch thick tenon before I do that. Here's what it looks like. Okay, and that looks like it's exactly a 1/2 inch, if not a 64th under. So we'll use that. Cut the other board now. This one's been cut. Okay, so now we've got both of our boards that are getting the tenons cut. So we can take off the clamps. And here's what this one looks like. We should probably verify that it's 1.5 inches. Okay, and it looks like that is exactly 1.5 inches, and because I'm using a rip profile blade, these are straight down here. So now we've got to take off the cheeks next. And we'll be using the back fence here to do that. So now I'll have to get the clamp set up, and unfortunately here I don't have any pockets that the clamps will fit into, so this will be a little more challenging to clamp these when we're making the cuts. So we'll just do it like that and like this. Okay, so now I've got to move the rip fence so that we have this board once again is 3 inches wide. So I need to have 2.5 inches to the inside of the tooth so that we get it cut to the right thickness. Okay, it moved on me, so let's verify it here. Yeah, that looks good to me. Check it up here. Okay, that looks good. Okay, so we'll just verify that we've got this up against the jig, and it is. So let's make our cut now. We've got to be a little bit careful because it's going to be coming out the back side of this portion of the jig, whereas it wasn't doing that before. Okay, it doesn't look right because I was not measuring to the fence here. I was measuring back to the fence there. And so I need to make another adjustment. And I noticed when I was looking down that the board would have been cut in the wrong place. So I need to move the jig over some more now. Okay, 2.5 inches. Okay, that looks good. Lock the fence down. Alright, so now let's try it again here. Okay, that looks like it's in the right spot. tenons cut on both sides of this board, both ends of this board. Now we're ready to block the second hole. Okay, so we've got both of the boards cut now. So now we just need to remove these corners. Actually, we need to remove an entire section here all the way across, and then again all the way across, and again all the way across, and again. So we'll use the miter gauge for that, and I'll get that set up, and then I'll double check to make sure that the miter gauge is at 90 degrees in case it shifts. Okay, I have the blade lowered down to a 1/2 inch above the table. I've set the rip fence here so that the distance from the rip fence to this outside edge of the tooth is 1.5 inches, and then I've pushed the rip fence back so that it ends before we start making a cut into the board, so that way there's room for the waste to drop down without causing a kickback. And that would be a rather nasty kickback in this situation. If your rip fence does not shift backward like this, then you'll want to mount a stop block onto your rip fence, or find some other way of setting a stop point out here. Okay, so we're ready to make the cut now. And as you saw there, that was a potentially nasty kickback that we avoided because that fence was backwards. Because that fence was back instead of being right up against the blade. So there's the cut that we got. Okay, so let's make the other cut. Now we can expect a little bit of rejection down there. Now I can tilt it up on its edge, make the same cut. Like I get less of a nasty kick when I do it on the edge like this. Those are just gentle little kicks. so now we have two sets of tenons cut, and these are very smooth, and that blade really did a nice job of minimizing the amount of tear out that you get on the back side of the cut. So there's what the tenon looks like on the one end, and here's the other end that looks equally good. And for the other tenon that was cut, it looks quite similar. Okay, so now we've got to figure out how to insert a square tenon into a hole that has rounded ends. So let's head back over to the workbench and we'll look at two different approaches. Okay, so we have rounded mortises here on the mortises that were cut earlier, and we want to be able to insert these tenons that we just cut over at the table saw. So let's look at a couple different approaches. One approach, which is the approach that I used 30 to 35 years ago when I was creating these English garden benches, was to use a rasp. This is just a rasp that I picked up at an auction a couple years ago. And so I can use that to quickly take down the corner. So let's point the camera down a little bit here so that you can see the corner of the workbench. Okay, so I've got the tenon here, the rasp, and I just take the rasp and just real quickly around the corner. It's not going to be perfect, but it only takes a couple seconds per corner. Okay, so there, that one is ready to be used. Another approach would be to use a chisel to just shave off the corner. Obviously, you've got to have a sharp chisel, and this is one that I had sharpened a few videos ago, and you got to make sure that you're not aiming this chisel where it could go into your hand. So it takes a little bit of careful consideration of where you're using that chisel. Okay, there's one corner. So you got to find the approach that you think works the best for you. This approach may be a little bit mellow, but you got a little bit of a drama that you're having a sharp blade heading right toward your body. You actually would find that this would be a less dangerous practice if you're using a sharp chisel, because it takes less pressure to advance a sharp chisel than it would be a chisel that's not so sharp. Okay, so we've got the corners worked out two different ways. So I'll raise the camera back up so that we can see this go together. Okay, so we'll take the end with the chiseled corners. We'll put it in. And that joint came together nicely. Okay, so let's see if we can take this out and try the other other one that was cut using a rasp. Okay, that went in just as easily. And obviously, you don't have to round off the corners of the tenons, even though that's probably the easiest thing to do. Instead, you could do the same thing that we did when we were using a drill press, or we were using the doweling jig. You can actually square up the corners, and maybe I'll try to do that on this edge here. If we square up the corners, then it's not that big of a deal. And depending on how hard the wood is, this may take a little more pressure. To get it right. Okay, so we'll take the tenon that still has square corners on it. We'll put that down inside, and that tenon was loose. This one here is also loose, so if you cut the tenons oversized in length, you may not need to square up anything. Okay, so there's a bunch of different ways that you can cut mortise and tenon joints. We'll have additional ways in later videos. Okay, now we'll go over to the PantoRouter and we'll see how the template was created to create a joint. Here's a test cut that was done. This is what's known as a Knapp joint. If it goes together, I haven't actually cut the second piece or a sample of the second piece. Here's a sample of a Knapp joint or Knapp joint that was created by Matthias Wandel on a PantoRouter. And here's the template that he custom designed using a CAD program. The first company that he sent his template program out to actually did not create the template quite right. The lines, segments, making these curves were a little bit too straight, and so that was unusable. So he sent it out to another company, and he got smooth curves. This was a couple years ago, I believe 2 or 3 years ago, when he created this video. And he was going to have the PantoRouter company create a template that they could release to their customers. That was 2 or 3 years ago. But so far, that template has not been released yet. And so I took a look at whether or not I could use a PantoRouter to create a template that looks something like this. This is my version of it, and obviously this is only going to do 3 of the 5 that he's got here, but I've got another template already mounted onto the PantoRouter that'll do 4, and that was used to cut this portion here. So I'm going to play back a video clip that shows how this template was created in case somebody else with a PantoRouter wants to attempt this Knapp or Knapp style joint. And then we'll try to create the full joint on the PantoRouter. I'm still waiting for a 5/16 inch spiral upcut bit to arrive. I found a white side one that's $60 that actually has a 1/2 inch shank. The 5/16 inch bit that they've got with a smaller shank is actually an 8mm shank, and that won't fit any of my routers, so I had to go to a 1/2 inch shank, and that bit was about $60. So I'm waiting for that bit to arrive. I did this test cut using a straight 5/16 inch bit, and it seemed to do okay, but I'm concerned that when I do the plunge cuts for these dowels, that's when I'm going to get either a lot of burning or it's just not going to advance. So those would be the dowel holes right here. I used a 1, 2, 3 block with a 2 inches to space out these dowel templates, and then I used the 1, 2, 3 block again to set the template holder height. And I've just got a board up here for doing some testing using the largest monster bearing. I want to see how large of a dowel template I can create down here in this board. I'm using the Amana 7-degree pattern maker's bit to create the template. Depth of cut is set to 1/2 inch. That might have worked out reasonably well. Now we need to cut the holes in the center. And for that, I'll set the depth of cut a bit shallower. Let's go to 3/8 of an inch. Now I'll replace the largest monster bearing fowler with the smallest bearing fowler that will fit into the center of these dowel templates. Here's what we ended up with. We may be able to use that as a template. Now I'll create a template using 4 dowel templates. Change out the bearing follower to the smallest bearing. Set the depth of cut to 3/8 of an inch. Here's the result. Here's the template cut down to 3 inches wide. In the center of each of these, I drilled a hole using an 1/8 inch drill bit, and then I had to countersink using a 1/4 inch drill bit, roughly an 1/8 inch down, so that the head of a screw would fit down inside. The screw is actually a machine screw. It's a number 6 that measures a 1/2 inch long, and then I have just a regular nut on here for a number 6 machine screw, and that's how I'll mount it onto the template holder back here in place of these templates, so that we can try to use this for cutting a joint. Okay, we're ready to create the Knapp or Knapp joint. And I have the PantoRouter partially set up now to cut this portion of the joint. And I've got a 5/16 inch spiral cutter bit mounted into the router. I have the tapered bearing fowler mounted into the PantoRouter, and it is roughly 1/8 of an inch from the back of the template. And that's where I had it when I made this test cut. And so I'm thinking that that's going to work. So what we need to do is to have a 5/16 inch dowel cut. And of course this gap through here will be 5/16 inch, as well automatically if I just carefully follow the templates that are here and not allow it to stray from that. I need to set the depth of cut. I have a cherry board and a black walnut board that are 4 inches wide and roughly 14 inches long, and so I'll use those for the 2 halves of the joint. The cherry board has a little bit of bug damage, so hopefully that's not going to interfere with our joint making ability. Okay, so I've got to set the board onto the table. I have the fence set exactly 2 inches from the center line using a ruler, and because the template is centered on the template holder left to right, that means that the pattern should be centered down here as well. Okay, so let's get this clamped with a board at least 3/4 of an inch out beyond the end of the table. Okay, now I need to set the depth of cut. So I'll butt that up and then get out a 3/4 inch setup block to set the depth of cut. Since my mating board is also 3/4 of an inch. Okay, so I've got the depth of cut set now. So now we should be ready to go, although I've got the template holder height set using 2 different setup blocks. I've got a 1 inch setup block, and then on top of that I have a 3/16 inch setup block. I found that that combination works pretty well with this template that I created. So I'll remove those, and now we're ready to get started. I need to be very careful that this template follower does not stray away from the template. I have to follow it exactly. Okay, so this board has been cut. Here's what it looks like. These should measure exactly 5/16 of an inch in diameter. I'll get the quick measurement on that just to make certain that that's the case. Okay, according to my calculator, 5/16 of an inch should be 0.3125. So I'll take a measurement here, and I'm getting 0.3105, 0.305, 0.306, and 0.315 exactly. Okay, now that we've checked that these are roughly 5/16 of an inch, only one of them is exactly 5/16 of an inch, we can move on to trying to cut the second half of this joint using the same template. Okay, we're ready to try to cut the lighter colored board here. We'll start out with cutting the dowel holes, and then we'll try to figure out a way to cut these scallops. I'm not sure if we'll be able to do that part or not. I have the cherry board mounted onto the vertical clamping jig, and it should be centered with a template side to side. I have the bit down here set so that when it's inside one of the holes here, I've got the smallest bearing follower stuck into the hole. When it's in that hole, the bottom of the bit is just over 5/16 of an inch from the bottom of this board, and then I've got another line marked 5/16 of an inch down from that, so that that'll be where the scallop comes in that you see here in the picture. Okay, I need to make sure that my depth of cut is at least 3/4 of an inch. So I'll use a 3/4 inch setup block and then add just a little bit. Possibly a 1/16 of an inch. So we'll end up cutting into this wasteboard back here ever so slightly. Okay, so now we're ready to cut the dowel holes. Okay, so we've got the dowel holes cut, as you may be able to see here. Now what we need to do is to find some way that we can get this to track further down, and I'm not sure if we can get a large enough radius or not. Let's see, maybe if we go with the largest bearing that we've got, and we can try that. And I don't know if that's going to get us far enough away, unfortunately, from the dowel centers here. So I'll have to drop the template holder down in addition to using this bearing, which is one size larger than the smallest. Okay, I'll drop it in, bring it out as far as I can while still remaining in the template. And we'll give that a shot. Okay, so now I've got to drop the template holder height down so that when this bit is at the bottom of its stroke, it's going to be touching the other line that I drew in here, or actually just below that, so we can pick it up in multiple passes. Okay. Alright, so let's give this a shot and see if it works. I don't know if that's going to work or not. Let's try to take it all the way up and we'll see what happens. Okay, I know that it's not going to fit right now, but let's take a peek at it and see how it looks. I'm thinking that to get this joint to go together the way it was intended to be fit together, I'd have to make some modifications to the template when it was originally created. I'll have to get a larger monster bearing or create one using a hole saw and possibly the 1-inch custom bearing that I created, and have it so that this area here, that's roughly 5/8 of an inch from this edge right here, gets cut away by the router bit. And the only way that I can think to do that is to have a much larger monster bearing than the largest one that's supplied with the PantoRouter, and so that it can reach out to here and clear away all this material. And that may be a possibility then, where the bottom of this template could then be used to cut the curve that matches this profile here. Okay, so let's try to make a different type of a cut on the PantoRouter. This will be a through tenon for a mortise and tenon joint. Okay, the plan here is to create a through mortise and tenon joint, to have a mortise going through this board in the center across using a 2.5-inch wide template, and I'll be making a tenon into this black walnut board, which is 3 inches wide and 3/4 of an inch thick. And that should go all the way through and just barely poke out the other side. So I've already got the PantoRouter set up to cut the mortise into this board, into the center. I set the height of the template holder to 3 inches using this board. And then I've got the depth of cut set to just over 1.5 inches, so that this 1/2-inch spiral bit that's in here should just come through the other side. Now once again, I'll be using dust collection, so you won't have a clear view of the cut, but this will help eliminate a lot of sawdust in the air, so I'm going to use it. Cut all the way through, and because I've got this bearing fowler all the way to the back of the template, it should have created a very tight fit once we cut the tenon on the other board. Now I need to set the fence so it's 1.5 inches off the center line of the table. So that the tenon will be centered on the end of this board. And now I've put my board up. I can take these stops off to get them out of the way, since they won't be used right now. And now I'll get the clamps. And I've got to make sure that this board is extending out at least 1.5 inches from the end of the table. Okay, I need to set the depth of cut and the height. I should be able to just use a 3/4 inch setup block to set the height so that the tenon will end up in the center of the board. So I'll do that. Or if I had used the board, instead of clamping it down to the table, I could have put it up here first, and that would have also worked. Okay, I need to set the depth of cut. Okay, there it's touching. So now I need pretty much exactly 1.5 inches. I may go a little bit over 1.5 inches, just so that it sticks through slightly. And you might put a bevel or something like that on this little bit that sticks through to make it kind of a decorative joint. Okay, so I've got that set just over 1.5 inches, the depth of cut. And now I need to get the 22mm bearing fowler. Okay, and I'm going to set that just to the right of the second line that's on the top of the template. And that's so that the center of the bearing here is just to the right of center of the second line that's right here. And that should give me about 1/2 inch. I may need to make a couple cuts to get it exactly to 1/2 inch, but we can start there. Let's just check that and see how we're doing. Okay, that's going to be a little bit too tight. So I need to move that bearing out just ever so slightly. Okay, let's see how it works here. And we're still just ever so slightly tight. We could probably hammer that in to make it fit. But I'm going to take off just a very small amount more. It would go on, but it would take a little bit of force to get it to go on. Okay, I moved it ever so slightly. Okay, I think that'll work. I'll take it off the table here and hammer it together, and we'll see how it looks when it's assembled. Okay, so here's the joint fully assembled. It's extremely tight. As you can see here, there's no gaps anywhere around. Here's what the side of it looks like. And there's other options for the PantoRouter for through mortise and tenon joints. We may look at those in a future video. But this went together just as I had hoped that it would, with a little bit of the tenon sticking out, and we could profile that to add a little bit of extra detail to it. And obviously, if I didn't want that additional portion of the tenon sticking out, I could have set the depth of cut to exactly the thickness of this board, and then it would have been flush right here. Okay, that's all for today. Thanks for watching. Bye.